Hey everyone, welcome to Simplilearn's YouTube channel. Today, we will learn about the top 3 cloud service providers, which are GCP, Azure, and AWS. That said, if these are the type of videos you'd like to watch, then hit that like and subscribe buttons and the bell icon to get notified.
Welcome to this tutorial about Google Cloud Platform, and here we will learn about cloud computing. What is cloud computing? What is GCP? That is your Google Cloud Platform. What are the benefits of Google Cloud Platform and what are its different services? A little bit about Google's infrastructure, a comparison of different cloud providers such as Google offering GCP, that is Google's cloud platform, Amazon offering Amazon Web Services, and Microsoft, which offers Azure. We will also learn about Domino's Pizza use case and then have a quick demo on using some of the services on GCP. Before we begin, let's understand why cloud computing. And it would be always good to learn about cloud computing based on a use case. There are varied use cases where organizations are adopting or moving their solutions or their infrastructure into cloud, or I can simply say integrating with cloud. Now, here is one use case. Nina started a company that relates to website development. The challenges which Nina was facing were low memory space whenever required for processing or for any other kind of application related work, high traffic to website that crashed it, and also less number of servers. Now, with these challenges, she was then referred to concept of cloud computing and how that could benefit and help her in solving her issues. Most of her issues were solved when she started using cloud computing, and with cloud computing she could increase her memory space as required, that is on demand, control the load to the website, that is basically load balancing and handling more requests on the website or requests per minute, buying servers at a lower price, that is scaling up or down based on the requirement. When we talk about cloud computing is use of hardware and software components which a cloud provider offers as a service, which can be accessed over network. Cloud computing is use of these resources, which could be either dedicated resources or coming from a pool of resources which cloud provider offers to deliver a service to clients. Users can access these different services, applications, files from any device which can basically access internet. Cloud computing allows automatic software integration. It allows backing up and restoring of data. It basically offers unlimited storage, memory, or computation capacity. It gives access to reliable sources, which usually the cloud provider themselves are using for their use case. And it is a cost-efficient model, which helps organizations to quickly integrate or basically modernize their infrastructure. Cloud computing is usually used with IT or within IT space, wherein there are 5 traits. If there is a requirement of resources as the business dynamically changes or grows. So for this, cloud computing offers on-demand self-service. So users could be using on-demand computing resources or memory resources, storage, network, and so on provided by cloud provider, and also do a self-service. All this is possible using a simple interface, and users can be using processing power, storage, network as they need and pay as they go. So there is least or no human intervention required. When it comes to projects which might need scalable network access, cloud computing offers broad network access, that is accessing resources over network across geographical regions or what we call as availability zones, which might be multiple sites within a particular geographical region. Cloud providers also have what we call as resource pooling. So this basically provides a huge pool of resources which are shared and can be accessed by customers at a lower cost. Now, there might be customers which are interested in not sharing the resources and would be interested in dedicated resources. And in this case, cloud provider also have sole tenant offerings which help such customers. If an IT business or any other business needs rapid elasticity, then cloud providers also have resources which are offered, which are elastic. You can get more resources rapidly as needed, and thus you can scale up and down. Think of a gaming company which would be interested in launching a new game, and they would have predicted a certain number of users which would get onto the portal playing the game. And what happens if the request per minute, or if the number of users who are joining in might increase? Now, in this case, organization would want an underlying solution which handles this dynamism, scales as needed on demand, and once the demand is done, scales down. This is possible using a cloud computing solution. Cloud computing solutions also include measured services, that is pay as you go model, for the usage or for the reservations which a user or organization would have made for resources offered by cloud computing. So when we talk about cloud computing, one of the questions which always arises is, why is this model so compelling? Why is this so interesting for organizations or users who would want to use one or many services from cloud computing? So first wave of trend which brought storage cloud computing was what we call as colo, that is co-location. IT shops that have been using or managing huge amount of data from decades basically wanted to build their infrastructures to handle their business needs. Now, instead of building costlier data centers, they would rent space or share facilities, and this was being done by organizations even in past. Thus, they would free up the capital for other use cases. Now, this was more of user configured, managed, and maintained by them. Later, organizations started thinking of virtualization. So that was again user configured, but provider managed and maintained. So components of a virtualized data center matched that of a physical data center, and organizations would have virtual devices separately managed from underlying devices. Then later came container-based architectures, or basically automated services. So within Google, services are automatically provisioned and configured, letting your infrastructure scale on demand. There are various reasons why an organization would think of integrating with cloud or benefiting by using cloud, and thus instantaneously reaping the benefits of modernizing their infrastructure. Now, few famous cloud providers are here. So you have Amazon, which offers Amazon Web Services and a huge list of services which come in with this. You have Microsoft's Azure, you have Oracle's Cloud, you have SAP's Cloud Solutions, GCP, which is offered by Google, Salesforce, and so on. There are many other small players which are also providing different services which are cloud-based, or organizations which are partnering with these main cloud providers, thus offering cloud services to their customers. When we talk about why Google Cloud Platform, there are various reasons why someone would choose Google Cloud Platform. GCP has better pricing compared to its competitors. When it comes to speed and performance, it is very fast and increases the performance of the project. Live migration of apps, and there are huge number of solutions which I will show you further in further screens, which help an organization to adopt to a cloud platform or integrate with cloud platform, or even completely migrate into a cloud platform. None of Google's competitors provide live migration of apps. When we talk about big data, AI, machine learning kind of solutions, GCP provides a lot of innovative solutions in comparison to other cloud providers such as AWS, Azure, and so on. So, what is Google Cloud Platform? It is a set of cloud computing services provided by Google that runs on the same infrastructure that Google uses to and for its end user products like YouTube, Gmail, and so on. Let's learn about benefits of Google Cloud Platform, such as high productivity, working from anywhere, quick collaboration, high security, fewer data stored on vulnerable devices, reliable resources which can be used across organization, across geographical regions, across countries, very flexible, which allows organizations to scale up and down as the demand rises or as the demand declines, and cost-effective solutions for various use cases. These are some of the benefits. And if we look into different services which Google Cloud Platform offers, we could look into detailed benefits which each service offers in a different use case, which basically helps organizations working in different domains, handling different kind of small, mid, or larger businesses, and with different business goals. When we talk about Google Cloud Platform services, here is a list of services, or I could say high-level domains or categories of services. So you have compute related services, you have storage and database, you have networking, big data, developer tools, identity and security management, Internet of Things, cloud AI, management tools, and also data transfer solutions. When we talk about Google's infrastructure, Google has one of the most powerful infrastructure in the world. The infrastructure is available in two levels, the physical and the abstract layers. You have physical infrastructure and then you have the abstract infrastructure. Physical infrastructure consists of data centers, extensive development of high efficiency backend data centers. You have a very strong backbone network, which is used by Google itself and also offered as services to customers via GCP platform services. So you have global meshed redundant backbone network. Points of presence, when we talk about Google, it has 110 plus edge points of presence in more than 200 countries. And when we talk about edge caching platform at periphery of their network. So this is what defines the physical infrastructure of Google. Now there is much more to it rather than just these 4 points. When we talk about abstract infrastructure, that is divided in global, regions, and zones. When we talk about zone, a zone is roughly equivalent to a data center and a single point of failure. So you could have your compute engine, which is within a zone, or you could say compute engine is a zonal resource. You have regions, which are geographical areas which contain multiple zones. So you could have a region for US Central or Europe Central, Europe West, and so on. And within a region, you would have one or multiple zones, and zones basically would allow high availability of resources. So you have cloud load balancer as an example, which is regional resource. Then you have global resources, and they are available and shared across the planet. So you have various global resources such as network, which could be even your IP addresses and so on. Now let's do a quick comparison of AWS vs Azure vs GCP, and let's look at what each cloud provider offers. Later we will also look into different services in detail when it comes to Google Cloud Platform, what each service does, what you can benefit from, which service should you use in what case. We will learn about those in later slides. If I compare your different cloud providers, When we talk about Amazon and its cloud offerings, that is Amazon Web Services or AWS as we well know it, Amazon Web Services has 69 availability zones within 22 geographical locations, and soon it will have 12 more in future. So this number keeps growing based on the spread of the services which a particular cloud provider offers. Here we are talking about availability zone specific information. When we talk about Microsoft's Azure, it has 54 regions worldwide and is available in 140 countries across the globe. When we talk about Google Cloud Platform is available in 200 plus countries across the globe. When we talk about virtual servers, Amazon's EC2, that is Elastic Compute Cloud, it is a web service which basically helps to resize your compute capacity where you can run your application programs on a virtual machine. So using EC2 service, you could launch virtual instances that could have any distribution of Linux, Windows. You could have different specifications when it comes to RAM or CPU cores or disk. You could also decide on what kind of storage a particular instance should use, whether the storage should be local to the instance or whether that should be an elastic file system or even an object storage. When it comes to Azure or Microsoft's offering, Azure Virtual Machine, that is infrastructure as a service, gives a user the ability to deploy and manage a virtual environment inside a virtual network on the cloud. And this virtual network on the cloud would be managed by cloud provider. Google Cloud or the offerings from Google Cloud Platform, that is GCP VM instances, enables users to build, deploy, and manage virtual machines in order to run different kind of workloads on the cloud. Now, when we talk about compute engine, here it would be good to discuss a little bit more about compute engine and what are the different options which Google Cloud offers. So when you talk about your compute engine, you have scalable, high performance virtual machines. Compute Engine delivers configurable virtual machines which run in Google's data center with access to high performance networking infrastructure and block storage. And you could select VMs for your needs. That could be general purpose or workload optimized. And when we talk about workload optimized, you have predefined machines or you have custom machine sizes. You can integrate compute with other Google Cloud services such as AI or ML and go for your data analytics. You have, when we talk about your GCP VM instances, just to expand on that, you have general purpose instances, which we call as N2, which provide a balance between price and performance, and they are well suited for most workloads, including line of business applications, web servers, and databases. Google Cloud also offers compute optimized instances, which we call as C2 instances, which offer consistent high-end virtual CPU performance, which are good for AAA gaming, EDA, HPC, and other applications. Now, when we talk about compute optimized or general purpose, how would we leave memory optimized instances? Those are M2 machines, which Google offers. So these offer highest amount of memory. These VMs are well suited for in-memory databases such as SAP HANA, real-time analytics, and in-memory caches. So if I would summarize this, when we talk about different instances, AWS also offers different kind of instances which are memory or compute or disk optimized. You have general purpose, and each category of machines has a different pricing model. You can always go to an AWS website, look for the pricing models, and that will give you an idea of on-demand instances or dedicated instances, reserved instances, and so on. Similarly, if you talk about Google Cloud also has instances with various options, which become the key features of why customers would choose Google Cloud Platform, such as live migration for VMs. So Compute Engine within your GCP can live migrate between host systems. And when I say live migrate, It basically means without rebooting, which keeps your application running even when the underlying host systems require maintenance. You also have preemptible virtual machines, wherein you can run batch jobs and fault tolerant workloads on preemptible VMs to reduce your virtual CPU and memory cost by up to 80% while getting the same performance. So these are your preemptive or preemptible virtual machines. The only demerit is these can give you a really cost efficient resource usage, however, can be taken off the shelf anytime. And that's why we call them preemptible virtual machines. You also have sole tenant nodes, which are physical compute engine servers dedicated explicitly or exclusively for users use case. And when we talk about sole tenant nodes, these are usually good when you are dealing with or when you're working with your applications, which we call as bring your own license applications. So sole tenant nodes give you access to same machine types and virtual machine config options as regular compute instances. So there are different options which Google Cloud offers when it comes to these instances which we are talking about, and it takes care of different use cases in comparison to other cloud providers which are also offering these services, such as you can have predefined machine types, you can have custom machine types, preemptible VMs, as I said, live migration of VMs. You can use persistent disks, which could give you durable high performance block storage. You have local SSDs. You also have GPU accelerators, which can be added to accelerate computational intensive workloads such as machine learning, simulation, medical analysis, and so on. And you have features such as global load balancing, which makes Google Cloud a unique choice. When we talk about platform as a service, Amazon has platform as a service offering, which we call as Elastic Beanstalk. Among one of its services, it's an orchestration service for deploying applications and helping in maintaining these applications. Azure Cloud Service provides a platform to write the user application code without worrying about the hardware resources. Google App Engine is a service used by developers for building and hosting applications on Google's data centers. When we talk about serverless computing, so Amazon's AWS Lambda is a serverless compute service. It is used to execute backend code and scales automatically when required. When we talk about Azure, you have something called as functions, which allow users to build applications using serverless simple functions with a programming language of their choice. When we talk about Google Cloud, GCP has cloud functions, which is easiest way to run your code in the cloud, and it is highly available and fault tolerant. So in these days, when we are talking about microservices architecture, which organizations are preferring, when we are talking about organizations which can scale, which can dynamically change their underlying architecture, organizations would be interested in serverless computing, where they do not have to have a infrastructure set up planned in advance before going for their use case. And this is where monolithic applications are really not a preferred choice. A lot of organizations are decomposing their applications into microservices based on business capability or decomposing based on subdomains. We can learn about microservices architecture later, but just to know that serverless computing, which basically helps any organization, if, for example, if you have a web application that receives non-linear traffic and you cannot keep an eye on your server always, it would be good to have someone to auto scale your application. Serverless is basically a computing model where cloud service provider is responsible for managing the piece of code without the developer having to bother about infrastructure setup, management, maintenance, and so on. Now, when we talk about applications being serverless or benefiting from serverless computing, one of the key things would be zero administration, so deploying application without any provisioning and management. auto scaling capability, that is, let the service provider worry about scaling the application up and down. You have pay per use model, which any customer would want to benefit from, that is, pay only for the resources that you have used or that you are continuing to use, right? Shorten the time between idea implementation and deployment, and this is something which any organization would want, that you would want a faster bring to the market solution timeline in comparison to getting entangled with deployment, management, and maintenance of your underlying infrastructure when your applications are facing a high demand. So when we talk about serverless, it is a function as a service, because each part of your application is divided as functions and can be hosted over multiple service providers. You have serverless apps, which are usually divided as separate units or functions based on functionalities or domains and so on. So serverless computing is gaining quite popularity these days in comparison to the traditional three-tier architecture, where you had a presentation layer, you had an application layer, you had a database layer. Now that kind of infrastructure is not really preferred in today's modern times when organizations are working on different kind of newer applications. When we talk about object storage, Amazon has simple storage service, that is S3. It provides object storage, which is built for storing and recovering information or data from anywhere over the internet. Azure comes up with blob storage, that is binary large objects storage, offers large amount of storage and scalability. It stores the object in the tiers and depending on how often the data is being accessed. Now same thing applies to even S3, which is from Amazon. So S3 also has different kind of storage classes which can be selected when a user or an organization intends to use a storage service. And when I speak about storage classes, it basically means having a frequent access storage or a infrequent access storage, or what we call as just an archival solution. Google Cloud has cloud storage, and it provides unified object storage for live or archive data. This service is used to store and access data on GCP infrastructure. When it comes to advantages, Amazon Web Services has enterprise-friendly services, easy access to resources, increase in speed and agility, and that too on demand, and takes care of your security and reliability of resources which are offered. When it comes to Azure, it has better development operations, strong security profile, provides a lot of cost-effective solutions, and operation execution friendly. When we talk about Google Cloud, one of the key features here is better pricing than competitors, live migration of virtual machines, which really interests a lot of organizations would want to modernize their infrastructure without having any kind of disruption in their existing services, improved performance, redundant backups, and so on. When it comes to disadvantages, in AWS, you have limitations when it comes to EC2 service. Well, there are different options in the kind of machines which you can choose, which you can work on. You have a technical support fee, which is incurred, network connectivity, and then also downtime, which might be in case when you're migrating. Azure, it has different code base for cloud and premise. Platform as a service ecosystem is not really as efficient as infrastructure as a service. Poor management of GUI and tools, integrated backup. When we talk about Google Cloud, support fee is quite hefty. It depends on what kind of solution or support you would or organization would be interested in. It has a complex pricing schema, although it has different use cases for which any user or any organization can benefit from. Downloading data from Google Cloud Services is an expensive option. Storage might not be. However, uploading data or downloading data would be an expensive option. When we talk about Domino's Pizza use case, now while we were discussing about these features, I would really want to spend more time in discussing each of these features or services in detail, such as you have compute engine, you have storage, you have Bigtable, you have Dataproc, and so on. So there are a huge list of services. Now, before we get into your Domino's Pizza use case, let me show you this page on Google Cloud where you can look at different services. So if you go to cloud.google.com and if you look at get started option under doc, so here you can find build solutions, look at different use cases, learn from basics of what is your Google Cloud, what are cloud basics. Then you can look at different cloud products. So here you have products in different categories such as AI and machine learning, API management, compute, containers, data analytics, databases, developer tools, and so on. And you can always click on any one of these to look into different solutions which are being offered, what are the different use cases, what are the best practices when it comes to migrating VMs to compute engine or operating containers or building containers and so on. You can always look at featured products, and that gives you a quick snapshot of what are the different products, such as you have compute engine, you have cloud run, BigQuery, which is a data warehouse, you have cloud SQL, which is a managed MySQL or Postgres, you have cloud storage to basically push in any kind of data there, you have security key enforcement, AI and machine learning, and so on. So you have different featured products. Now if you scroll down to the lower end of this page, you can again look at different solutions, and that would be really interesting to read and learn from. So you have infrastructure modernization, you have application modernization, you have data management, and so on. So if I look at infrastructure modernization, you could basically look at the solutions which Google Cloud offers and what it does when it comes to having your infrastructure modernized or benefiting by integrating with cloud and having immediate benefits of infrastructure modernization. You can look at different use cases, what they are doing, how Google Cloud really helps when it comes to migrating the workloads to a cloud, and how your different cloud solutions such as VM migration, you have SAP on Google Cloud, VMware as a service, and so on. And you could learn from these different solutions which are offered. You can also look at application modernization. So not only infrastructure modernization, but organizations would also be interested in relooking at their applications, relooking at how these applications could be moved from monolithic to microservices architecture, or how applications can benefit from modernization and cloud computing offerings. So you have again different use cases here, uh, which talks about different ways in which Google Cloud can help, how you can modernize your applications, how you can use different solutions which Google Cloud is offering. Now, when we talk about cloud computing services, you can always go into cloud.google.com. If you have created a free account, then you can just log in, and every user by default gets a $300 free credit, so wherein they can try out different products, where they can use different services. So here, if I click on console, where I'm already logged in with my Gmail account or my Google Cloud account, wherein I have $300 free credit, out of which some is being used. You have a Google Cloud console, and here from the hamburger menu, you can click and you can look at different services within different domains. So you have compute domain, which has different services such as app. You have compute engine, and that basically allows you to use your VM instances, which we were talking about previous slides, different instance groups, create your templates, use sole tenant nodes, create snapshots or backup of your data, use different zones. You can go for Kubernetes, which is containerized based engine. You have cloud functions, you have cloud run, and then you have storage related different options such as Bigtable, you have data store, Firestore, file store, storage, and so on. And for each of these services, you can read about from the Google's documentation, or anyways, I will be explaining that later. You can also look at networking related, operation related, and other tools which are offered by Google Cloud. So these are huge list of services which Google Cloud Platform offers in different ways for different use cases. Now, let's look at this Domino's Pizza use case and see what it helps us learn about. So you can always access this page by going to this link which talks about customers and then which shows you different use cases. So Domino's increasing monthly revenue by 6% with Google Analytics Premium, Google Tag Manager, and Google BigQuery. So this is basically when Domino's started using GCP and what was the result of that. Now let's look further into this. So we all know that Domino is most popular pizza delivery chain operating across the globe. But how was that possible? Let's take a look. So the challenges were they wanted to integrate marketing measurement across various devices, connecting CRM and digital data to create a clear view of customer behavior, to make cross-channel marketing performance analysis easy and efficient. Now, for these challenges which Domino's was facing, the solution was using Google Analytics Premium, Google Tag Manager, and BigQuery, which were used to integrate digital data sources and CRM data. Reporting was made easier and more efficient by implementing Google Analytics Premium because it had the ability to access a single Google Analytics account to evaluate web and app performance. By using the new Google Tag Manager implementation, Domino's were able to act fast. They were able to connect CRM data with digital analytics, which basically provided Domino with greater visibility on customer behavior. What was the result? There was an immediate 6% increase in monthly revenue, 80% of costs in ad serving and operations were saved, increases agility with streamlined tag management. They obtained easy access to powerful reporting and customized dashboards. Now that was just one simple use case. Before we go on to hands-on, we can also talk a little bit back about the services which Google Cloud offers, as we discussed, and some of these services which can really make you think, why not Google Cloud Platform? So when we talk about your different cloud platform services, let's learn about some of these services in brief, in what each service is, what it does, and how it can help us in handling our use cases or working with different products. So let's learn briefly about different services which Google Cloud Platform offers. Now, one of the domains is compute, and then let's look at the compute services which GCP offers. Now here I can log into the console, and this hamburger menu on the top left corner, I can click on this one and go into the compute engine section. So this is the compute domain, which has app engine, Kubernetes engine, cloud functions, and cloud run. So these are your different services which are offered within the compute domain. And here we can get into compute engine by clicking on this one and then basically going to VM instances. So before we see how we can use this compute engine, let's understand about some of the features of compute engine, which basically offers scalable, high performance virtual machines, which are configurable and which runs in Google's data center with access to high performance networking infrastructure and block storage. So from here, you can select VM for your needs, for your general purpose or workload optimized, predefined or custom machines. Now here you can integrate compute with other Google Cloud services such as AI, ML, and other data analytics services. You have different machines which are offered here, such as general purpose, which provide a balance between price and performance, which are well suited for most workloads, including line of business applications, web services, and databases. You also have compute optimized machines, which offer consistent high-end virtual CPU core performance and which are mainly good for gaming, EDA, high process computing, and other such applications. Apart from general purpose compute optimized, you also have memory optimized machines which offer highest amount of memory. And these VMs are basically well suited for in-memory databases such as SAP HANA, real-time analytics, and in-memory cache. Now, we can see these options here. You can click on VM instances while you're logged in into your Google Cloud Console. Here, you can even create an instance template which can be used to spin up instances. For example, if I click on new VM instance from a template, there are some templates which I have already created for my usage. Now here, I can basically use one of these templates, or what I can do is I can go back, I can go into instance templates, and this basically allows me to create a template. So you can click on create instance template, which basically allows you to create templates which can be used to spin up different instances. We can give a name to the template. For example, we can say template instance. Now here I can choose machine configurations, and this is where you have different options. So you have general purpose, as I mentioned, which provide a balance between price and performance. You have memory optimized, which are large memory machine types for memory intensive workloads. You also have compute optimized, which basically give you high performance machine types for compute intensive workloads. So you can choose any machine configuration which is available here based on your requirements. Now, if you click on general purpose, that has different options here. So you look into the series where you have N1 series, you have E2, which are CPU platform selection based on availability. You have N2 and N2D. So let's just have N1 selected. Now, you also have here, which talks about machine types. And here we can choose the configuration which we are interested in. Depending on the applications which will run within the machines, we can choose a machine. So by default, it shows one virtual CPU core and 3.5 gigabyte of memory or RAM. You could choose a higher end machine. So as of now, I'll just say N1 standard. Now that basically allows me to choose these machines. So there are different features which your compute offers, such as you have live migration for VMs, you have preemptible virtual machines, you have sole tenant nodes, and all those options can be seen here. Now in this machine, for my boot disk, I can select a distribution which I would be interested in. For example, I could be going for public images, and I can choose, for example, Ubuntu. And then I can choose a version. So it shows me 16.04. And you also have latest versions such as Ubuntu 20. You can choose one of these. And here it asks you to choose the boot disk type. So that could be standard persistent disk, which is HDDs, which are low in performance and you can say low in cost in comparison to SSDs. So SSDs give you better performance, but then they are little expensive than using standard persistent disk. We can choose this and we can give a disk size, for example, 20 gigabyte, and I can click on select. Before clicking on select, I can click on custom images, and that shows me if you have any other images created in your project, you could use those. You could also learn about images by clicking on this link. So we'll click on public images. We have chosen this distribution. Let's do a select. And now here you have identity and API access management. So let this be default. You can say allow default access. And what you need is, depending on the services, we can choose it allows HTTP and HTTPS traffic. Now, we would also need some way to connect to these machines. So when you set up an instance, by default, you can do SSH into it using the Google Cloud Console or from Cloud Shell. You can also give a private and a public key. So here you have the option where you can give all these details. So when it comes to management, it tells you would you want to go for reservations, and you can say automatically use created reservation. You could also say no, you would not want to use a reservation. You can also set up or provide a startup script which you would want to give whenever your machines come up. And here you have the options of preemptibility. So compute offers preemptible virtual machines. So that is mainly when you would want to run batch jobs and fault tolerant workloads on these machines, and you can benefit with a reduced cost for your virtual CPU and memory by 80%. So these are virtual machines which would be lasting less than 24 hours. Now, by default, this is off, and it purely depends on your workload, what you would want to run on these instances. I could just go ahead and select preemptible being on that and use this feature of compute. You also have on-host maintenance, which talks about what would be happening with this compute engine instance. So when compute engine performs periodic infrastructure maintenance, it can migrate your VM instances to other hardware. And this is one of the features which compute engine offers, which we call as live migration for VMs. Here, your compute engine can live migrate between host systems, that is the underlying systems on which these VM instances are based on, without rebooting, which will keep your application running even when host system require maintenance. And here it says migrate VM instance recommended, and let that be as it is. You can also say that if there is a maintenance happening, you can terminate the VM instance. Now, it also talks about automatic restart, which is on, which basically means compute engine can automatically restart VM instances if they are terminated from non-user initiated reasons. So these are all the settings which are available in management, and it also tells us the different features which we have. There is also a feature called sole tenancy, which basically means sole tenant nodes which can be chosen. So you can have physical compute engine servers dedicated exclusively for your use, and this is usually good when you're talking about bring your own license applications. So sole tenant nodes give you access to same machine types and VM configuration options as regular compute instances. However, these might be a little expensive. We can choose this one. We can also look into networking, which basically shows the default setup, which goes for auto subnet. You can also choose a particular IP if that is required, but that would cost more. You can click on disks, which talk about what do you want to do with the boot disk when the instance is deleted, what is the encryption mechanism you would want to use. And here, finally, you have security. So basically, as I said, you can SSH into instance using the Cloud Console option, and you can also provide a public SSH key. So one way of doing that, if you intend to use an external SSH client such as PuTTY to connect, you can create a key. So for example, I can go into PuTTY Gen, and here I can say generate, just move my cursor over here, and that will create a key. I can give a name to this one. So I'll say SDU will be username. I'll give a simple password, which I will use to log in to this machine. And then I can save this private key, which will get saved. So let's say SDU new key, and this gets saved in a .ppk file, which is usually used when you use an external SSH client to connect. So save this one, and that saves a ppk file on your desktop. What you can also do is you can copy this public key content from here, and this is what we would want to give in our instance here. So that the public key gets stored on the instance, and private key is what we will use to connect. So once I paste it here, it resolves the name to HTU, and we have given the public key. Now in certain cases, you may want to use a software which uses SSH to connect to the machine, and that software might not be such as your PuTTY. So in that case, you may want a PEM file or a private key which is saved as a .pem file. So you can also do that by going to conversions and do a export OpenSSH key and then save it. So I'll say HDU new key, but then this one will be saved as a PEM file on my machine. So you have ppk file, which allows you to use PuTTY to connect to the instance. You have a PEM in case a software needs directly SSH to these machines. You also have the public key, which we have already provided in the machine. Now, once this is done, I can close PuTTY Gen. I can go back to this page where I'm creating an instance template, and then I can just click on create. So this has created an instance template, which I can use to spin up my instances, any number of instances using the same template. Only thing which I would have to do is change the region where I would want the instance to run. So now that we have created instance, and that's this one, the third option, I can go back to VM instances. Now I can click on create, and here I can either create an instance from scratch by giving all the details again, or I can just use my template. So I can click on new VM instance from a template, choose my template, click on continue. And once this is done, I can give my instance name. So let's say C1. I can choose the region. So I will choose Frankfurt, and then rest everything is auto populated based on the template what you have given, and you click on create. Now this basically allows you to spin up an instance, and you can create any number of instances using your template. You could have already created a new instance right from scratch. Now once the instance is created, this has a public IP and a private IP. Private IP will not change unless you would want to set up a new machine, but public IP will change every time you stop and start the machine. Now this is what we need to connect to this machine. I can also do a SSH from here by doing this and open in a browser window. Let's click on this. So this is an internal way of connecting to your instance using SSH. Let's wait, because it would be transferring the SSH keys to the VM. It establishes a connection, and I'm connected to my machine. What we can easily do is to confirm if we are in the right machine. We can just do a ls to look at the file system. What we can also do is we can basically log in as root by doing a sudo su, and that allows you to get into the machine as root. And from here I can switch to HDU user, which will have a .ssh directory in home, and that basically has authorized keys. And if we would want to see if this one contains my public key, I can just do a cat.ssh and then look into authorized keys, and this shows me the public key which we had initially added to our instance. So this confirms that we are logged into the machine which we created. Now I can close this, and what I can also do is I can copy this public IP. So let's do a copy to clipboard. Now go to putty, and here I will say hostname, where I'll say HDU, give my public key. I'll click on SSH, and in SSH I'll go to authentication. Now here we need to give our PPK file. So the PPK file was HDU new key. Select this one, come back here, come to the session, give it a name, for example C1, save it, and then you can just say open and say yes, and you are logged in to your machine. Now once you're logged in, you can always do a -SSH, and that shows you the file. So this is how you have just used the compute engine to spin up an instance, but we used a template which basically allowed me to create this instance, and then I can connect to this instance, and then I can start working on this. So when we talk about features of compute engine, it has predefined machine types as we saw. So compute engine offers different predefined virtual machines, and they have configurations for every need, from small general purpose instances to large memory optimized instances with up to 11.5 terabytes of RAM. You can have fast compute instances optimized up to 60 virtual CPU cores. You also have custom machine types, so you can create a VM that best fits your workload, and by tailoring a custom machine type to your specific need, you can realize significant savings. There are preemptible VMs, which we saw. There is also a facility which allows you to take the benefit of live migration. For VMs, you have durable high performance block storage for virtual machine instances in the form of persistent disks, where data is stored redundantly for integrity, flexibility, and to resize storage without interruption. And you could be choosing HDDs or SDDs for your instances. Now you also have options such as GPU accelerators. So for example, if I just click on create instance, and I can look into that. So here, let the instance name be instance 1. And what I would be interested in looking at this one, which says CPU platform and GPU. So CPU platform configuration is permanent. You can also do add GPU. So GPUs can be added to accelerate computationally intensive workloads like machine learning, simulation, medical analysis, and virtual workstation applications. So you can add and remove GPUs to a VM when your workload changes, and pay for GPU only while using. So these are some of the features which basically compute engine offers, and we already know that Google bills in second level increments, so we only pay for the compute time. Now there are different savings which are possible. So you have commitment savings, which basically means you can save up to 57% with upfront cost per instance type lock-in. You have container support, so you can basically run, manage, and orchestrate Docker containers or Compute Engine instances. So here, when we are setting up our instances, there is an option which basically allows you to use or deploy Docker images. Now that can be done. You can also benefit from sustained use savings, that is sustained use discounts, which are automatic discounts for running Compute Engine resources for significant portion of the billing month. You can create a reservation for VM instance in a specific zone, which is basically seen under your management section here. And you can ensure your project has resources for future increases in demand, and if no longer needed, delete the reservation. So these are some of the features of Compute Engine. What we have done is we have created Compute Engine using the console. Now you can go back. You can also do that using Cloud Shell, and you can click on this one, which activates Cloud Shell. You could also have the Cloud SDK support set up on your machine, which can be used. Now I can just open this in a new window, and from here I can start giving commands if I would be interested in setting up an instance from my command line. So here you have different options. Now to begin with, you can just do a G Cloud and just hit enter, and that will show you different options which are available, which can be used. So you have G Cloud Compute here, which shows an option to create and manipulate Compute Engine resources. Now I can just do a Q to quit. I can do G Cloud Compute, and that basically will again show me different options which are available if you would be interested in setting up instances from the command line. So here I can say G Cloud Compute and then go for instances. And if you do not know the commands, you can just hit enter. That will show you all the different options which we have. So here we have different options such as list or create or start or update. For example, I can just do a list here to see what instances I have. And the instance which we just created shows up here. It says that status is running. I can just stop this instance. I can delete this instance. I can even create an instance by using a create command here, and you can just do a create help, which will show you what are the different options you can give. So it says instance name is what you need. You can choose an accelerator, you can choose the boot disk, and various other options. So I can just say create, and then I can give a name, for example C2, and once I click on this one, it says, did you mean Europe West 4 zone? So it is asking me for the region and the zone, and I can say yes. And these settings are coming from my default profile. I can always change those by changing the metadata. So now we have created an instance. It says running. If we do a list again to see, we see 2 instances created. One was in Europe West 3, one was in Europe West 4. Both of them have internal and external IPs. Now you can do a describe to look at the different options here. So G Cloud basically allows you different commands which you can use to work with your instance, to create instances, to change the metadata. If you would want to change the region, if you would want to add a startup script, all those options are possible from the command line, which we can learn in detail in later sessions. So this is your Compute Engine as a service. Now that we have learned about the compute domain and compute services, which is offered by GCP, let's also learn about storage and databases. That's again within the storage domain and the services which are offered by Google Cloud Platform. Now you can go back to console, and here you can click on this one. And here you can just scroll down to see what are the different options in storage. So you have options such as Bigtable, you have Data Store, Firestore, File Store, you have SQL based services, you have storage, which is object storage, and then you have other options which are available. So Google Cloud Platform offers different storage based services, out of which storage, which is your object storage, is quite popular one. Click on storage, and that basically shows you an option which talks about storage browser. So this is your Google Cloud's object storage. So when we talk about object storage, it is basically a storage where you could store any kind of data. And when we talk about object storage, it is a bunch of bytes which we address, wherein every object will have a unique key. These unique keys are in the form of URL, which allows you to access the object. So cloud storage is comprised of what we call as buckets, which are used to store and hold your storage objects. These storage objects are immutable, and every change creates a new version. Now you can also have control access via IAM, that is Identity Access Management, or via Access Control List. So there is also an option called object versioning, which basically says if it is on, every time you try to store the same object, a new version of the object would be created. Otherwise, newer option will override old one, as we cannot archive the old version. So let's see how we work with this object storage. So here you can click on create bucket. Now once you click on create bucket, it needs a name. So let's say test bucket. And here I can just give, say, number 1. So that says this is the name of my bucket. Now I can directly click on continue, or it would be good to look at different options which are available here. So when you click on choose where to store your data, so it already gives me an option. It says the bucket name is already taken. So let me give it a unique name. So let's say test buck, and let's call it AUA. So that should be unique. Now here it says choose where to store your data. So this one gives you location type. So you can have region specific buckets which give you lowest latency, that is fastest response time within a single region. However, it does not make your storage highly available. You can make it dual region, which is basically allowing your bucket or storage to be accessible across regions. You can also make it multi-region, which is highest availability offered. As of now, we can choose region specific, and now it asks you to choose a location. Now, as always, I will choose Frankfurt. Now I can click on continue and let all the storage options be default, or you can click on a default storage class. Now that tells you based on your storage class, there are variant costs when it comes to storing, retrieving, or doing any kind of operations. So you have a standard option which says best for short-term storage and frequently accessed data. You can also go for cold storage such as nearline, which is best for backups and data access less than once a month. You can go for freezing storage such as cold line, best for disaster recovery and data accessed less than once a quarter. Or you can go for archiving where the data is accessed less than once a year. Let's go for standard as of now. And now you can choose how to control access to objects. So you have fine-grained or uniform. Let it be fine-grained, wherein you can give additional permissions at bucket level using IAM, or object level permissions using access control list. In advanced settings, you can choose the encryption, and you can also choose a retention policy. So a retention policy to specify the minimum duration that this bucket's objects must be protected from deletion or modification after they are uploaded. You can always learn about this more by clicking here. Now, once I've chosen all the relevant options, I can click on create, and that basically will create a bucket by the name I have given. I can click on overview to basically see brief details about my bucket, such as region, what is the default storage class, and it also shows you the link URL which can be used to access your bucket. It also gives you the link for gsutil. Now gsutil is a command which can be used in your Cloud Shell to basically work with your buckets. You can click on permissions to basically see what kind of permissions are already in place, and you can then make changes. You can basically add members. You can view by different roles. So for example, here by default it shows other services such as Dataproc or your bucket owner or bucket reader related permissions which have been already granted. Now, once I've looked at my bucket, I can start using it. I can drag and drop and push in files here. So as of now, there are no live objects in my object storage that is in my bucket, what I can do is I can click on upload files, and then I can choose a location from my machine. For example, I'll go into data sets, and what I can do is I can choose some of the files here in any format. Let's choose CSV or text and just to open. So this one will basically upload my data sets here. Now, once I've uploaded the files, I can basically close this one. I can look into options here which says edit permissions, edit metadata, if you would want to download it, if you would want to copy, move, or rename it, if you would want to export to a different service called Cloud Pub Sub, which is Publish Subscribing Messaging System, you can scan the data. Now you can click on a particular file, and that basically shows you the URL, which basically allows you to access this file. You can try copying this. You can click on download and download this file. You can even try accessing this from public, and that basically shows you the content of this file based on the permissions. So this is basically your object storage, which is one of the service which is offered. What you can also do is you can create folders, and within folders you can then upload your data. So this is your Google Cloud storage option, which is for your object storage. That is, you can add different items, you can give different permissions, and you can use this Google Cloud Platform's storage service offering. Now you also have other options such as Bigtable, and we can go into that by clicking here and click on Bigtable. So Bigtable is one of the service which kickstarted NoSQL databases. Today in market, we see different NoSQL databases such as Cassandra, HBase, MongoDB, CouchDB, Neo4j, and many others. So you can basically use Bigtable, which was the pioneer when it comes to your NoSQL databases, or not only SQL databases. So the problem initially faced by Google was that the web indexes behind search engine were taking too long to build. So company wanted to build database that would provide real-time access to petabytes of data. And that's where Bigtable began. So Bigtable powers different other Google services such as Gmail, Google Maps, and other services. And in 2015, it was launched as a service for customers. So when it comes to scalability, with use of Bigtable, you can increase your machine count without any downtime, and you can handle admin tasks like upgrades, restarts, and so on, which are basically taken care by the cloud provider. Data present in Cloud Bigtable is encrypted, and you can use IAM roles to specify access. So data written to or from Bigtable is through data service layers such as managed virtual machines, HBase REST servers, Java services, HBase client, and so on. Here, if I would want to use Bigtable, I can click on create instance, and that basically tells me Cloud Bigtable instance is a container for your clusters. Now here you can give an instance name. So for example, I will say AUA and then say, for example, test, and let's say Bigtable. So that will be the name of instance. This will be permanent. You can choose the storage type. Again, you can go for lower latency, more rows read per second, typically used for real-time serving use cases, or you can go for SDDs, which have higher latency for random reads, good performance on scans, and typically used for batch analytics. So let's go for SSDs as of now. Here you have cluster ID, which is auto-populated. You can choose a region. So let's go for our favorite one here, where I can say Europe West 3. I can choose a zone here, and I can then choose how many nodes would I want to use for my Bigtable. So when you talk about Bigtable service, it will have a cluster underlying, which will have various nodes, which will control your data throughput, storage, and rows read per second. So as of now, let it be just one node, and that's enough for our demo. When we talk about performance, it basically tells you based on the current node and storage type, it tells you how many reads can happen at milliseconds. So it says 10,000 rows per second at 6 milliseconds. You have writes which are 10,000 rows per second. or you have scans which are 220 megabytes per second. Storage which is taken care here would be 2.5 terabytes, and I can then basically click on create. Now there is also some option called replication guidance, which basically says replication for cloud table big table copies your data across multiple regions, enabling you to isolate workload and increase the availability and durability of your data. Depending on your use case, you can have big table which can be used to have your data across regions. Now you can click on create with all your specifications chosen, and that's going to set up a cluster, or you can say a fully managed NoSQL database, which will give you low latency and replication for high availability. Now, once we have a new instance, you can connect to it with the CBT command line tool. And for instructions, you can click on learn more here. You can just click on this instance ID to see the details again if you would want to look into your big table setup. So it tells me here that we have one instance, what is the CPU utilization time, how many rows were read or written, what is the throughput, and this is auto-populated based on your usage. You can click on monitoring, and that basically will give you different widgets which will display information for your CPU utilization, what is your hottest node, depending on how many nodes you have, system errors, automatic failovers, storage utilization, and so on. You can click on Key Visualizer, which will allow you to look into your table if you have already created some data here, and you can click on Tables to see how many tables you have added here. So that's in brief about your big tables, which is one thing which we need to remember is it's not good for all use cases. So should be used for low latency access, that is fast access, and good if at least data is greater than 1 terabyte. For smaller amount of data, the overhead is too high. So big tables performance will suffer if you store individual elements larger than 10 megabytes. If you want to store bigger objects such as images, video files, then go for object storage, and that would be a better option. So always remember, big table is not a relational database, it's a NoSQL database. And when you talk about multi-row transactions or online transaction processing, big table is not the right choice. So it can be used for wide range of applications, especially when you talk about your OLAP, that is online analytical processing. So it is designed to store key value pairs, and there can be different use cases. So for example, if you're using something like Cloud Data Flow or Cloud Dataproc, where you would want MapReduce kind of operations, big table can act as a good storage because it has very high throughput and scalability. And the best thing is that it supports HBase API, thus allowing easy integration with Apache, Hadoop, and Spark clusters, which you can bring up using one more service which Google Cloud Platform offers, which is called Cloud Dataproc. So big table is good for real-time analytics. It's commonly seen in financial services, IoT, and others. And if you are thinking of running interactive SQL, then big table would not be the right choice, but the other choice would be BigQuery. You should also remember that this has a cluster running, and you would be charged if this cluster kept on running. So you have to be very careful in your free account when you're using such services. Now we have clicked on this one, so I can select this one, and basically I can look at the permissions, I can look at the labels, I can look at inherited permissions here. I can also click on my instance which we created, and either you can edit or you can just do a delete. So as of now, we will just delete this, which needs you to give in the name. So we'll say AUA test BT and then click on delete. So whenever you're trying out different services, the first approach should be setting up these different services, seeing how they work, basically trying connecting to them. And once you are satisfied with the initial test, then you can plan your actions and come back and use the service for a longer duration. Now that's your big table, which is one of the offerings. We can go back into storage, and here you have other options which are available. So for example, we were in big table. You also have an option such as Cloud Data Store. Now that's one more service which is offered by Google Cloud Platform when it comes to storage domain. So Google added software on top of Bigtable, which supports more than simple key value pairs. When you talk about secondary indexes, instead of just having one primary index, when you talk about asset properties for reliable transactions such as SQL query like language, so these features or these services were added to or on top of your Bigtable, which gave birth to a new service which was released as Cloud Data Store. So this is where you have Cloud Data Store and you can select a Cloud Firestore mode. So you can go for a native mode, enable all Cloud Firestore's features with offline support, or you can go for Cloud's data store system on top of Cloud's Firestore. So these are different options here. And here we look at the API or scalability, engine support, how many writes it supports, and so on. You can choose one of these, and then you can choose where to store your data. So for example, if I click on this one, then it asks me to choose a location. So it says the location of your database affect its cost, availability, and durability. Choose a regional location, lower write latency, lower cost, or multi-region location. Here I can basically choose, for example, Europe, and then I can go ahead and create a database. So it says initializing Cloud Firestore in data store mode services in EU3. This usually takes a few minutes. You'll be redirected to your database once it is ready. So if we compare the pricing structure between Cloud Data Store and Cloud Bigtable, always remember Cloud Data Store, you pay for monthly storage, which is also in the case of Bigtable. However, here you are paying for monthly storage for reads and writes. But in case of Bigtable, you are paying for cluster when it is running. So Cloud Data Store is a good option for small data, infrequent access, and it acts cheaper. When you talk about large amount of data or big data and frequent access, then you're talking about Cloud Bigtable. So Bigtable is cheaper when you talk about larger amount of data. So here it says, since your database is empty, you can still switch to Cloud Firestore in native mode to get more features. You could do that. You could learn. You could say query by GQL. As of now, we don't have any data here. Let's look at the dashboard, which says since your database is empty, you can still switch to Cloud Firestore in native mode to get more features. So this is your Cloud Data Store, and it has many features which help you to work with your data. However, some features or important features of RDBMS were still missing, and that's where Google created yet another Bigtable based service called Cloud Spanner. Now we can continue working on Cloud Data Store, which basically gives you one option to work with your data. You can create an entity here by clicking on create entity, and that basically gives you options such as default namespace. You can give a kind, you can give numeric ID, and you can start adding properties. But to learn more about data store, we will learn about this in further sessions. So as of now, I'm going to click on cancel. I'm going to go back to my data store, and this basically, let's go to data store option, or I can go into admin here, which basically says if you have entities, you can import or export them. So let's go back and let's again look into storage options. So as of now, we were in data store. Let's click on this one. So as I mentioned, your Cloud Data Store, which basically gives you some additional features on top of your Bigtable. But what Google also did was it realized that there was a need for RDBMS feature support. That is, there were a lot of features. Now here we have created a data store, and it says your database is ready to go. Just add data. You can create entities, start putting in data, and then you can go ahead and query this. So if you would want to learn more about your data store, you can just click on this one, and that takes you to the complete documentation of native mode and data store mode. What is Firestore in native mode? What is in data store mode? What are pricing and locations? How you choose a database mode? What are the feature comparisons? What you can do, what you are allowed to do here, what programming languages can be used, different regions, pricing, and so on. As of now, we'll click on this one, and let's look at one advanced service which Google Cloud came up with when it comes to your additional features of RDBMS. So Google created yet another big table-based service called Cloud Spanner. Now that you might not see here, but if you scroll down, you should be able to see your Cloud Spanner in the options here. Or did we miss it on the top? So let's again look here. Yeah, so it is here and you can click on Spanner. So Cloud Spanner was released in 2017. It basically supports relational schema. So it offers strong consistency for all queries, which can be SQL based. You can have multi-region deployment. Now, when it comes to massive scalability requirement and strong consistency, Cloud Spanner is a good option. So it says Cloud Spanner is a managed, mission critical, globally consistent and scalable relational database. So if you would want to use this, then you will have to enable this API, which shows you an option here. It says try this API. So it's a managed service. So it is one of the Google's most expensive database services. There is also one more database service, which is Cloud SQL, which can be used. So when we talk about your Cloud Spanner, it is fully managed relational database service. It is massively distributed. You can have millions of machines across hundreds of data centers with support automatic sharding and synchronous replication. It gives you low latency and schema updates without downtime, making data high availability and reliability. So we'll learn about Cloud Spanner with more details later in other sessions. Now, we can also go back to storage and we can look at the different options which we have here. So you have object storage, you have Spanner, you also have your SQL based service, which is yet another managed service offered by Cloud or Google Cloud, I would say. So that's called Cloud SQL. So this is basically a service which allows you to have fully managed relational MySQL, Postgres, and SQL Server databases. Google handles replication, patch management, database management, and other things which are related to this managed or fully managed database service. It can allow you to handle terabytes of storage capacity with 40,000 IOPS with huge amount of RAM per instance. So you can click on create instance here and then you can choose one of the database which you would want to use. So Cloud SQL is a managed service. You can choose one of your MySQL or Postgres and SQL Server. Say for example, I choose MySQL. Now that basically tells me what is the instance ID. It sets up a password. You can always change the password. You can change the region. You can choose your database version. And then you can also look at other configuration options which talk about machine type, which will be used, what is about your backup and recovery, maintenance, and all that. And if you click on create, this will basically create a fully managed SQL service, which can allow you to straight away start using MySQL on cloud, thus allowing you to store your relational data. When we talk about storage options, how can we not talk about a data warehouse solution or basically an option which allows you to run your queries by directly updating data? So you can use a data warehouse service which Google Cloud Platform offers, and that's called BigQuery. So basically you can be looking into the big data section here, and here you have an option called BigQuery. So this basically brings ease of implementation and speed. So building your own data warehouse can be expensive, time consuming, and difficult to scale. So with BigQuery, you just load data and pay only for what you use. So when it comes to features, you have features such as capability to process billions of rows in seconds. And if you would want to do real-time analysis of streaming data, that is also possible here. So here we have clicked on BigQuery, which basically shows you the option where you can start typing your query and test your data access. For example, if I have uploaded some data, so it shows me there are some queries which are saved here. Now I can schedule a query. I can basically choose the format of a particular query by clicking on this more. Here I have an option which says add data. So I can pin it to a particular project. I can explore public data sets. I can create a connection. So if I click on explore public data sets, then it takes me to a page from where you can get different kind of data sets which are already available, which you can put into your BigQuery and start querying your data. By default, it shows that it is aligned to my project and I don't need to worry about it. I can look at saved queries if I have already saved a particular query. I can look at job history. I can look at transfers, scheduled queries, and reservations. So BigQuery basically initially had its own version of SQL, which was slightly different from standard SQL. But in 2016, BigQuery 2 was released that supports SQL 2011 standard. You can always select standard SQL. Now, BigQuery, when it comes to pricing, we need to remember that the storage cost is very less here, approximately 0.02 cents per GB per month. It is almost similar to Nearline, where you can also have low cost, that is 0.01 cents per gigabyte per month. There is no charge for reading data from storage. When it comes to querying, and that's where the cost is incurred. So 1 terabyte per month is free, and after that it costs few cents per gigabyte. So this is mainly for high volume customers. There is a flat rate pricing which can be used. So when you talk about querying, you can save your query results. You can create data set to store the results. Now results are put in a temp table in cache. And after you're done with that, you can delete data set and delete all the data. So when you talk about loading data into BigQuery, you can get the data from cloud storage, Google Drive, Cloud Data Store, Stack Driver, Stack Driver, other options. You have Cloud Bigtable or other web interfaces. So you can download from URL such as CSV, JSON, Avro. You can create dataset, create table, and create from source by doing a file upload. So 10 megabyte or less files can be uploaded using web interface. As an option, you can also use command line, and then you can start working with your BigQuery. So here you can also work with streaming data by basically pushing in streaming data into your BigQuery, which allows you to add one record at a time. Now you could use something like Cloud Data Flow, which allows you to use a particular pipeline. About Cloud Data Flow, we will learn later. So you can benefit from different features of BigQuery and thus use Google's offering to work on your structured data, or I would say data which suits well in data warehouses. Now, these are some of the storage related services which Google Cloud offers. Although we will learn about using BigQuery and running or uploading some data by creating add data set here, by say creating connection or using a public data set. So as of now, I have this. You can also access the command line to work with this, but we will learn in detail about BigQuery in later sessions. Now here, you can scroll down and you also have an option within big data space, and that is your Dataproc. So when you talk about Dataproc, this is again a managed service which allows you to run Spark or Hadoop jobs. So especially if you are interested in big data workload. So for big data processing, for machine learning, you can always use Cloud Dataproc. This uses compute engine instances under the hood, but takes care of management of these instances. So it's a layer on top to spin up clusters. It's a managed service. It's cheaper, pay when the jobs are running only. It's fast because it is integrated with other Google Cloud services. You have open source components pre-installed, and Dataproc is integrated with Yarn to make cluster management easier. When you talk about Dataproc, you can click on create cluster, and that basically allows you to set up your cluster by choosing a particular region which you would want to use. For example, I'll choose Europe West 4. Here it tells what kind of machines you would want to use, and by default it has populated as the machine here, which is 4 CPU and 15 gigabyte. Now since you might be using a free account, let's not go for the high-end machine. Let's go for N1 standard 2. and then you can scroll down. It says what is the primary disk, what is the disk type, and this one was for your master machine, that is machine which will have the master processes running. Then you have your worker node configuration, which tells this will be, let's choose a lower end machine, and we can choose how many worker nodes you would have. So it says minimum 2. You can choose the SSDs and their capacity. It talks about yarn cores and yarn memory which will be allocated, and here we have then option of clicking on create. So once you click on create, this will basically spin up a cluster wherein you can straight away start submitting jobs to this. You can basically go ahead, once your cluster is ready, you can go into the cluster, you can submit a job, you can choose a type which is Spark or any other application which you would want to run, and then basically you can use this fully managed service which allows you to run your big data clusters. You can obviously control access via roles or access control list, and you can have access as it is at project level or based on your Dataproc cluster or even at your worker nodes. So we'll learn about Dataproc in later sessions. So as of now, you see here the cluster is getting created. It says the cloud storage bucket which it is using is this one. Now I can click on this and open link in a new tab. It still takes me into console, but now it is showing me the bucket which is being used by your Dataproc cluster. This is the bucket which is being used, and it is being used for underlying metadata which gets stored here. So you look at the cluster related folders, you can click in these folders and then it can see what is the script output, what it is doing, and so on. Now I can come back here to my bucket, which will basically show me what kind of buckets have been created. So you see Dataproc service automatically created some buckets which will be holding some data. You also have some other buckets which were created based on other services which we used. The access control is fine grained in all cases, plus it also shows our bucket. So underlying, it is using compute instances. It is basically using, let's go here and let's go to compute engine and let's look into VM instances. So Dataproc, which has spun up a cluster, is also using the VM instances which we see here are running. It is using the buckets and it has made a cluster ready to use. So you can click on this cluster and that shows me my cluster related details, if there are any jobs running, what are VM instances, what kind of configurations it has used, and you can look at different details here. You can look at the logs, you can click on jobs, and that will show you if you have basically run a job on this ready to use cluster. So it says there is this particular job which was run, which was a Spark job. You can click on submit, and this one tells you what is the job ID, what is the region you would choose. For example, we will again choose, for example, Europe West 4. It tells what is the job type. So you can run all these type of jobs in this cluster, such as Hadoop, Spark, PySpark, Hive, Pig, Presto. You can give your jar file. So if you have packaged your application as a jar, you can mention that here. You can pass in some arguments. You can also say some other jar files, add some properties, and then click on submit, which will run your job on this ready to use cluster. Now, since we have tested it, I can basically go ahead and do a delete. I don't want to incur any cost on these managed services which are running. So there are a lot more information about using these services which Google Cloud Platform offers, and we can continue learning about these services as we explore your Google Cloud Console or even your command line option. Now we can come out of this one by clicking on this menu, and then we have other options such as Kubernetes, you have cloud functions, you have your networking related services, monitoring related services, different kind of tools what you have other big data specific services which you can learn about. And for each of these services, Google has a very good documentation available. For example, when you talk about publish subscribe messaging system, it is a real-time managed service which basically is a pioneer which was used, and now you have a famous service such as Kafka, which is being used for your publish subscribing or messaging system kind of requirements. So to conclude about Google Cloud Platform services, you can always go to cloud.google.com and look into the document section. Now here you have list of different featured products. You also have list of your different domains and services which Google Cloud offers, and you can learn about all the different services which are offered by Google Cloud. Here you can click on featured products, and that basically shows you compute engine, cloud run, cloud storage. You have cloud SQL, BigQuery, Vision AI. You can scroll down and look at your artificial intelligence and machine learning related services, platform and accelerators, API management. So Google Cloud Platform offers different services in mainly in your compute, storage and databases. You have networking related services, big data specifics, developer tools, cloud AI, identity and security, IoT management tools, API platform, and so on. So basically learn about the GCP services which Google Cloud Platform offers, and in detail you can play around with different services which are offered by creating a free account, and as I demonstrated, you can use any one of these services, quick start them, basically connect to them, put in your data, or use a managed service to manage your data and benefit from Google Cloud Platform, thus having modernized infrastructure for your different use cases.
Azure. First, let's understand what is Microsoft Azure. Microsoft Azure is a growing set of cloud-based computing services offered to corporations, developers, government, and anybody else who wants to build an app or run a business on the internet without having to install and manage hardware or server software. In recent years, it has eclipsed both Windows and Office in terms of sales, making it Microsoft's fastest growing business sector. The Azure platform is designed to assist organizations in overcoming obstacles and achieving their objectives. It supports a wide range of industries, including e-commerce, finance, and a number of organizations. And it is open source compatible. This gives consumers the freedom to use whatever tools and technologies they want. Now, coming to how Azure works, customers who subscribe to Azure get access to all of the services available through the Azure interface. These services allow subscribers to create cloud-based resources such as virtual machines and databases. Azure comes with 5 different customer support solutions from Microsoft: Basic, Developer, Standard, Professional Direct, and Premier. The scope and cost of these customer assistance programs vary. All Azure accounts get basic assistance for free. However, Microsoft charges a premium for the other support options. Developer support is $29 per month, $100 per month for standard assistance, and $1,000 per month for professional direct support. Microsoft does not provide pricing information for Premier support. Now that we have covered the basics of Microsoft Azure, let's dive down and explore the services offered by Azure. Well, there are multiple services offered by Azure, like machine learning, analytics, containers, compute, databases, developer tools, DevOps, hybrid, and multi-cloud, identity, integration, Internet of Things, management, media, migration, mobile, networking, security, storage, web, and virtual desktop. But among these, we will be discussing only a few which are widely used by organizations and individuals around the world, and we will be vividly discussing these features in depth. And these services are compute, containers, databases, identity, security, networking, and storage. Now let's start with the first one, that is Compute. Azure Compute is a service that allows you to run cloud-based applications on demand. Disk, CPUs, memory, networking, and operating systems are among the computing resources it supplies, and the resources are on demand and can be accessed in minutes or even seconds. You only pay for what you use and for how long you use it. Azure offers a variety of computing solutions for development and testing, application deployment, and data center expansion. Linux Windows Server, SQL Server, Oracle, IBM, and SAP are all supported by the service. The following are some of the most well-known services: Azure Virtual Machines, Virtual Machine Scale Sets, Azure Container Instances, Azure App Service, and Azure Functions, or also serverless computing. Now let's discuss each of this one by one. First is Azure Virtual Machines. Virtual machines are software-based computer simulations. A virtual processor, memory, storage, and networking resources are among the resources available. Virtual machines, or VMs, run on operating system and allow you to install and run software much like a regular computer. You can use and operate the virtual machine as if you were sitting in front of it by utilizing a remote desktop client. Azure Virtual Machines allow you to construct and operate virtual machines in the cloud. Infrastructure as a service is provided through virtual machines, and they can be used in a variety of ways. Virtual machines are an excellent solution when you need complete control over an operating system and its surroundings. All of the software running on the VM can be customized just as on a real machine. Also, when you're running custom software or hosting arrangements, this capability comes in handy. Now coming on to the next one, that is virtual machine scale sets. Scale sets are an Azure compute resource that may be used to deploy and manage a group of identical virtual machines. Virtual machine scale sets are meant to provide real autoscale when all VMs are set up the same. Virtual machines do not need to be pre-provisioned. As a result, developing large-scale services for big computing, big data, and containerized workloads is easy. More VM instances can be added as demand grows. VM instances can be withdrawn when demand decreases. The procedure might be human, automated, or a hybrid of the two. Now moving on to the next one, that is Azure Container Instances. Container instances are Azure compute resources for managing and deploying containers. Containers are virtualized application environments that are lightweight. They're built to be dynamically formed, scaled, and stopped. On a single host machine, you can run many instances of a containerized application. Then comes Azure App Services. You can create, deploy, and scale enterprise-grade web, mobile, and API apps on any platform with Azure App Services. While employing a fully managed platform to handle infrastructure maintenance, you can meet stringent performance, scalability, security, and compliance requirements. A platform as a service solution is App Service. And following that, we have Azure Functions. When you simply care about the code that runs your service and not the underlying platform or infrastructure, functions are great. They are frequently used when you need to respond to an event, typically via REST request, a timer, or a message from another Azure service, and the job can be accomplished rapidly in seconds or less. Now that we have completed all the services offered by compute, let's proceed to the next one, that is containers. Containers are a type of virtualization system. You can run several containers on a single physical or virtual host, in the same way that you can run numerous virtual machines on a single physical host. Unlike virtual machines, you don't have control over a container's operating system. Containers are lightweight and designed to be built, scaled out, and stopped dynamically, whereas virtual machines appear to be instances of an operating system that you can connect to and administer. Containers are built to help you to react to changes on the go. Containers allow you to swiftly resume in the event of a crash of hardware failure. Docker is one of the most popular container engines, and Azure supports it. Containers offer these particular services: container instances, Azure Container Services, and Container Registry. Container instances are the quickest and easiest method to operate a container in the Azure without needing to manage virtual machines or use any extra services. It's a PaaS service that lets you upload your containers and have them run for you. Moving on to the next one are Azure Container Services. Azure Container Services or Azure Kubernetes Services allows users to manage, deploy, and control operations of a Kubernetes container. Orchestration is a term used to describe the process of automating, managing, and interacting with a large number of containers. Azure Kubernetes Service is a comprehensive container orchestration service for distributed architectures and high volumes of containers. And then comes Container Registry. A container registry is used to ease container development by easing storage and management of container images. Now that we have covered containers and the services offered, let's move on to the next Azure service, that is databases. Azure Database is a fully managed platform as a service database engine that automates the majority of database management tasks, such as updating, patching, backups, and monitoring. Microsoft has released a managed instance aimed at on-premises clients. So if we have any SQL databases on-premises that we want to migrate to Azure without any complex configuration or ambiguity, we can use managed instances. The most prominent services under database service are Azure Cosmos DB, Azure SQL Database, and Azure PostgreSQL. Now coming to the Azure Cosmos DB. Azure Cosmos DB is a multi-model globally distributed database service. You may increase throughput and storage across any number of Azure locations around the world in an elastic and independent manner. You can use any way of several common APIs to get single-digit millisecond data access. Throughput, latency, availability, and consistency assurances are all covered by Azure Cosmos DB's service level agreements. Now, Azure Cosmos DB enables schema-less data, allowing you to create extremely responsive and always-on apps that can handle constantly changing data. This functionality can be used to store data that has been updated and maintained by users all around the world. So next comes Azure SQL Database. Azure SQL Database is a relational database based on the Microsoft SQL Server database engine's most recent stable version. SQL Database is a fast, dependable, well-managed, and secure database. You may use it to create data-driven applications and websites in your preferred programming language without having to worry about infrastructure. So SQL Database's PaaS capabilities allows you to concentrate on the domain-specific database administration and optimization tasks that are vital to your business. SQL Database is a fully managed service with high availability backups and other typical maintenance features built in. Microsoft is in charge of SQL and operating system code changes. You don't have to worry about the infrastructure. Coming to the next one, the Azure PostgreSQL. Now, Azure Database PostgreSQL is a cloud-based relational database solution. The server software is based on the open source PostgreSQL database Engines community. When you use Azure database for a PostgreSQL, your experience with tools and knowledge comes in handy. Moreover, it has various benefits like in comparison to on-premises resources, there is built-in high availability to ensure that your apps are always online. No additional configuration, replication, or cost is necessary. Pricing is straightforward and adaptable. You can expect consistent performance thanks to a pricing tier that includes software patching, automatic backups, monitoring, and security. Within seconds, scale up or down as needed to ensure that your service adapts to usage. You can grow computation and storage independently as needed. Automatic backups can be customized and restored to a specific point in time for up to 35 days. And enterprise-level security to safeguard sensitive data in transit and at rest. This protection includes data encryption on disk as well as SSL encryption for client-server communication. Now we have covered one more crucial service offered by Azure. Now let's move ahead and explore another service, that is security and identity. These two services are integrated, so we will be discussing them together. Identity management in specific is a process of authenticating first and then authorizing using security principles. And it involves controlling information about those principal identities. It provides these important services: Azure Security Center, Key Vault, and very important aspect of Azure service, that is Azure Active Directory. Azure Security Center. First, Azure Security Center is a collection of tools for monitoring and managing the security of virtual machines and other cloud computing resources in Microsoft's public cloud. The Azure Security Center is accessed through the Azure Management Interface by administrators. They may find a number of security tools in the Security Center to help them prevent, identify, and respond to possible security risks to their Azure deployment. To use the Security Center, organizations must have an Azure subscription. Next is Azure Key Vault. Azure Key Vault is a cloud service for storing and accessing secrets in a secure manner. Anything you want to restrict access to, such as API keys, passwords, certificates, or cryptographic keys, is a secret. Vaults are managed, and hardware security module pools are two types of containers supported by the Key Vault service. Software as well as HSM-backed keys, secrets, and certificates can be stored in vaults. Only HSM-backed keys are supported by managed HSM pools. Coming to the next one is Azure Active Directory. Azure Active Directory, or Azure AD, is a cloud-based identity and access management service from Microsoft that allows your employees to sign in and access resources such as Microsoft 365, the Azure portal, and thousands of other SaaS apps. Internal resources such as apps on your company's intranet and network, as well as any cloud apps built by your company. Azure AD is required for sign-in and identity protection in Microsoft Online Business, such as Microsoft 365 and Azure. If you sign up for any Microsoft Online businesses, you will be given access to Azure AD, which includes all of the free services. Now we covered one more Azure service. Let's move on to the next service, which is networking. Now, Azure provides the scalability, performance, high availability, and enterprise-grade security. You need to satisfy your most extreme workloads requirements with more than 165,000 miles of private fibers across 60 plus regions and 170 plus network POPs around the world. Customers will have a consistent low latency experience thanks to service and integrate smoothly across on-premises, multi-cloud, and edge locations. So when you use Azure Networking's Network as a Service you can concentrate on delivering your application logic. Network Watcher, Express Route Monitor, Azure Monitor, or VNet Terminal Access Point are all Azure networking services that can be used to monitor your network resources. So the first one we will talk about are virtual network. Azure Virtual Networks allow Azure services such as virtual machines, web apps, and databases to connect with one another, with internet users, and with on-premises client computers. An Azure network is a collection of resources that connects other Azure resources. Isolation and segmentation. Internet communications communicate among Azure resources, communicating with on-premises resources. Route network traffic, filter network traffic, and connect virtual networks are some of the core networking features provided by Azure Virtual Networks. Next, we will talk about VPN gateway. A virtual network gateway or VPN gateway is a form of the virtual network gateway. Azure instances are installed in Azure Virtual Network instances and provide connectivity for services such as a site-to-site connection connects on-premises data centers to virtual networks. A point-to-site link connects individual devices to virtual networks, and a network-to-network connection connects virtual networks to other virtual networks. So now moving on in ExpressRoute, with the support of a connectivity provider, ExpressRoute allows you to expand your on-premises networks into the Microsoft Cloud over a private connection. You can connect to Microsoft Cloud services such as Microsoft Azure and Microsoft 365 using ExpressRoute. An any-to-any IPVPN network, a point-to-point Ethernet network, or a virtual cross-connection through a connectivity provider at a co-location facility can all be used for connectivity. So ExpressRoute connections are not made through a public network. As a result, ExpressRoute connections provide more reliability, quicker speeds, constant latencies, and higher security than traditional internet connections. Now we have reached the last service offered by Azure that we will discuss: storage. Microsoft Azure Storage Platform is a cloud storage technology designed for current data storage scenarios. A massive scalable object stored for data object, disk storage for Azure virtual machines, a file system service for the cloud, a messaging store for reliable communications, and a NoSQL store that are all available through core storage services. The services offered by are Azure Blob Storage, Azure Table Storage, Azure Queue Storage, and Azure File Storage. So the first one is Azure Blob Storage. Blob Storage is a Microsoft Azure service for storing binary big objects made up of unstructured material like text, photos, and videos, as well as associated metadata. Blob storage objects can be accessed through HTTP or HTTPs from anywhere in the globe by users or clients' applications. Blob storage objects can be accessed using the Azure Storage REST API, Azure PowerShell, and Azure CLI, or a client library for Azure Storage. Coming to the next one is Azure Table Storage. Large volumes of structured data are stored in Azure Table Storage. The service is a NoSQL data store that takes requests from both inside and outside the Azure cloud. Now, Azure tables are great for storing non-relational structured data. Table storage can be used to store and query large amount of structured, non-relational data, and it will scale as demand grows. Moving on to the next one, that is Azure Queue Storage. Azure Queue Storage is a service that allows you to store massive amounts of data. Authenticated HTTP or HTTPs call allow you access the messages from anywhere in the world. A queue message can have a maximum size of 64 KB. A queue can hold millions of messages, up to the storage of account's overall capacity limit. Queues are widely used to build a backlog of work for asynchronous processing. Now coming to the last one is Azure File Storage. Azure Files provides fully managed cloud files that can be accessed via the industry standard server, message block, or network file system protocols. Cloud and on-premises deployments can both mount Azure Files file shares at the same time. Windows, Linux, and Mac OS clients can access SMB Azure file shares. Clients running Linux or Mac OS can access NFS Azure file shares, additionally using Azure file synchronization. SMB Azure file shares can be cached on Windows servers for rapid access near where the data is used. So now that we have covered all of the important services offered by Azure and their functionality, let's dive deeper into the concept and look into how Azure is better than other cloud platforms. So first is Microsoft Azure PaaS gives developers the environment, tools, and building blocks they need to create and deploy new cloud services quickly. It also provides the critical DevOps linkages required for monitoring, maintaining, and fine-tuning such apps. Microsoft handles much of the infrastructure management behind the scenes with Azure PaaS. As a result, Azure deployment allows for a singular emphasis on innovations. Second is the compatibility of Azure with one of the most beneficial feature of Azure, and that is the .NET programming language, which gives Microsoft a significant advantage over AWS and the rest of the competition. Azure was designed and tuned to work seamlessly with both old and new apps built on the platform framework for .NET programming. Now, Azure was built using the security development cycle, which is a leading assurance process in the industry. It has security at its core, ensuring that private data and services are kept secure and protected while on Azure Cloud. Fourth is, on Azure, hybrid apps can be created that take advantage of resources in data centers at the service provider's end or within Azure itself. To increase usability and speed, Azure now offers a greater selection of hybrid connections, such as virtual private networks, caches, content delivery networks, and express route connections. Fifth is, if a company already utilizes Microsoft software, it is likely to be covered by Microsoft Enterprise Agreement. It is eligible to discounts on Microsoft software because Microsoft frequently modifies these agreements to reduce Azure pricing. As a result of the enterprise agreement, businesses can often get large discounts for adopting Azure. Let's have a quick demo for Azure services for their better understanding. So in this demo, we will first create a resource group and an SQL database for it, and a server also. So first you need to log in your Microsoft Azure account and then click here and go to resource groups. Click on create button. So for subscription, we will have a free trial option and give it a name according to our requirement. Like for now, I'm giving it Azure Demo Simply, and the region according to your area, like where you want to deploy your apps, that you will be publishing here, and click on review plus create. Here you will get all the information that you need to review that all the information here are correct or not, and then click on create button. It will take a few seconds. Now you can see this notification that your resource group is created, and here you can see that the name of your resource group, the subscription, and the location. So now what we need to do is we will create a SQL database for it. Here you can see all the details. So to create our SQL database, we will first need to create a web app. So where we need to go is we will go to app services, and here we will click on create button. And again we need to give it a first we need to select our resource group. So we will click on the resource group we just created, and we will give it a name. So here I'm giving it Azure Demo Simply Web App, and click on code, so that while publishing we can upload our code. And runtime stack, we can select the language we have created our application in, again the region, and click on review plus create. So here you can just review all the details you just mentioned. It's taking a while. Yeah, so here you can see subscription resource group which you just created, name you gave, and the publishing runtime stack. Now all you need to do is click on create. You can see it's initializing deployment. You need to be very careful with the region because sometimes it may create problem while deploying. You can see deployment is in progress. Now you can see your deployment is completed. So you just need to go to resources. Coming back to the page, you can see the name of your application you just created. Now as we are done with our web app, now we need to create our SQL database. So coming to the SQL database page, we will click on create button. Again, the subscription we have to give free trial, and the resource group we just created, because that's where we are publishing our web application, and that's where we need to attach our database with. So now we need to give a name to our database. So here I'm giving it Azure Demo SQL DB. And here you can see that we don't have any items to select as a server, so we will click on create new. Here we will create a server for our SQL database and give it a name. So I'm giving it a name. This is I'm giving it a name Azure Simply Server. As you can see, it's already taken, so I need to change it. So let's take Azure Demo Server. Yeah. So now we are done with the name. Again, for location, we need to mention the region. So here you can see I've selected. Now coming, here we have to enter our admin login. So here I'm giving my organization's name. I need to give it a password. Then confirm password. And click on OK. So here you can see that database name has already been attached to it, the database we just created. For Elastic Pool, we will go for no option only, and then again we will click on review plus create. So here you can see all of the information that you just mentioned, whatever privileges you will have with your SQL database, and click on create. You can see deployment has been initialized. It's gonna take a while. You can see the status constantly and track them. Here you can see deployment is in progress, and in a while you will see the name being flashed over here. Now you can see your deployment is completed, and in deployment details you can see your database being created and the demo server you just created. Now going back to your resource group, the one we created at first, clicking on the name, we can see all the tasks we just did, like creating a web app, creating a database for it, and also a server for your database. Now all you need to do is publish your application that you created for yourself and deploy it over here.
Let's look into what is AWS. AWS is a broadly adapted cloud platform which offers several on-demand operations like compute power, database storage, content delivery, etc. And that helps corporate scale and grow. AWS services can be used to create and deploy any application in the cloud. For example, it provides services over the internet just like World Wide Web, and AWS is the largest cloud platform available that you can use for either creating the application, creating the databases, likewise the other features also you can use simultaneously. Now, what are the benefits of AWS? The first is it is easy to use. For using the AWS, you require the good internet connectivity, and then you can actually browse it using the web console, and also you can use the command line interfaces as well. Second, flexibility. AWS offers you a flexibility so that you can actually change or tweak your solutions whenever you require. Reliability. So with the help of the redundant infrastructure across the globe, the AWS gives you the reliability that any application or any databases, if you are running on the AWS, that would be basically up all the time and there will be no or very less downtime. Then comes the scalability. So scalability is one of the important features of AWS, and in that case you can actually scale up your resources at any time you require. So for example, if any of your application is overutilized and you require more resources to run your application, you can do that on the fly. Then comes cost effectiveness. So AWS is a very cost effective platform because here, whatever the service that you use, that is charged on a per hour usage only. So you don't have to pay the complete cost like you do when you procure the infrastructure in the data centers. You don't have to basically pay for the complete package or usage of the service. You just have to pay for whatever time duration that you have actually used that service and the associated charges with it. And that makes the AWS a very cost-effective solution. Then comes the security. So AWS is a secure platform and a lot of measures have been taken so that the security can be enhanced and upgraded in the AWS. So from the infrastructure level, the AWS have a very high level of security that is implemented, and from the application and the solution perspective, it gives you a lot of features where you can actually apply the security as per your requirement onto your applications. Coming to the AWS services, so essentially AWS services are compute, storage, database, migration, networking and content delivery, developer tools, management tools, media services, machine learning, analytics, security, identity and compliance, mobile services, application integration, AR and VR, which is augmented reality and virtual reality, customer engagement, business productivity, desktop and app streaming, Internet of Things, which is IoT. Now let's look into the compute service, which is one of the widely used service on the AWS. And what does the compute service do? These services help developers build, deploy, and scale an application in the cloud platform, that is EC2, Lambda, Elastic Container Service, Elastic Load Balancer, Lightsail, and Elastic Beanstalk. These are the services which lie in the compute service section only. One of the most widely used service within the compute section is EC2, which stands for Elastic Cloud Compute. It is a web service that allows developer to rent virtual machines and help to resize the compute capacity. So here what you can do is you can run the virtual machines and you have the privileges to select the type of operating system that you want should be running on your instances or on your virtual machines. And likewise, later you can customize as per your requirement. Lambda is a serverless compute service. It is also responsible to execute code for a specific application. So those who are from the development background, they can focus more on creation of a code. They don't have to create a server, manage it. Instead, they can use a Lambda where they can deploy their code directly onto the Lambda server. Then comes the storage service. Now, couple of storage services are S3 Glacier, EBS, which is Elastic Block Storage, Storage Gateway. Now, AWS provides web data storage service for archiving data. Also, its main advantage is disaster data recovery with high durability. Let's look into some of the essential storage services, and one of the most widely used storage services is S3, which stands for Simple Storage Service. In the Simple Storage Service, what you need to do is you have to create a bucket, and in that bucket you have to put the files in it. So S3 gives open cloud-based storage service which is utilized for online data backup. Then comes the EBS, which is an Elastic Block Storage. Now you can understand EBS as a virtual hard drive also, which attaches with the EC2, and it provides high availability storage volume for persistent data. It is mainly used by Amazon EC2 instances. Then you have the database services. AWS Database Domain Service offers cost-efficient, highly secure, and scalable database instances in the cloud. And some of the database services are RDS, which is a relational database service, DynamoDB, the non-relational or NoSQL or NoSQL database service, Elasticache, and Amazon Redshift. Now, one of the essential database service is the DynamoDB. It is a flexible NoSQL database service which offers fast and reliable performance with no scalability issues. It is fast, reliable, highly scalable, and suitable for small scale applications like mobile applications, gaming applications, or anything with respect to the Internet of Things devices, there the DynamoDB is most widely used or suitable. Then comes the relational database service, that is the RDS, which is a structured database service. It is a managed distributed relational database cloud service that helps developers to operate and scale database in a simple manner. So RDS has different vendors platform with respect to the database usage, and that includes the PostgreSQL, MySQL, then you have Oracle, Microsoft or MS SQL, and they have their own customized database as well, that is called as the Amazon Aurora. Along with that, they have a Maria database or MariaDB as well. So these are a couple of vendors that give their database engines that you can use on the RDS. Now coming to the networking services, it offers a highly secure cloud platform and helps in connecting your physical network to your private virtual network with high transfer speed. Now some of the services in the networking and content delivery are VPC, which is a virtual private cloud, a very important service in order to make your applications or services more secure. Route 53, which is a DNS mapping service. Direct Connect, which directly connects with the AWS services and with your data centers. And the CloudFront, that is basically a content delivery service. Now coming to the VPC or a virtual private cloud, it helps a developer to deploy AWS resources such as Amazon EC2 instances in a private virtual cloud, so that you can actually make your EC2 isolated or make it more secure, and even you can make it for a public access also. Depends on the administrator that how they want to customize it. So the complete control of a VPC and its networking is with the admins. Then comes the Route 53 service. It is a web service with highly available domain name system or the DNS that helps user to route software by translating text into IP address, and that is why it is called as a DNS mapping service. And that helps you to use your domains or the external domains pointed to the AWS services in case if you use AWS for hosting your websites or the applications. Note, DNS translates text into the IP address. Now coming to the developer tool services, it helps a user build, deploy and run an application source code automatically. It also updates the server and instance on the workload. So first is the CodeStar, Code Build, Code Deploy, Code Pipeline. So CodeStar, it is a service designed to manage application development at a single place. Here developers can quickly develop, build and deploy applications on AWS. So all the managed app development can be done with the CodeStar. Code Build removes the hassle of managing physical servers and helps developer build and test code with continuous scaling. So security, identity and compliance services helps in monitoring a safe environment for your AWS resources by providing limited access to specific users. So in case, let's assume that you have to give an access to someone but with limited privileges, you can primarily use IAM in that case. And if you want to make your applications or deployments more secure, then you can use these services like KMS, IAM, Cognito, WAF, which acts as a firewall. Now, the IAM service, which is the Identity Access Management, is a framework that helps in maintaining access to AWS services in a secure way. So what happens is that the admin who has the complete access of the AWS console provide access to users, and there can be different users, and they would have the privilege accesses defined by the admin. So what type of permissions the admin gives them, they would have those limited access on the AWS console. KMS enables users to create and manage the encryption keys that are used for encrypting data. Coming to management tool services, with the help of management tools using this service, an individual can optimize costs, minimize risk, and automate all the resources running on the AWS infrastructure efficiently. So with the management tools, you can monitor the resources application, its tools and the utilizations, and along with that you can scale up, scale down the resources likewise. With the help of the management tools, you can also do the auditing task. So one of the essential service in the management tool service is the CloudWatch. It is a monitoring tool for AWS resources and customer applications running on AWS platform. So let's assume that you have used EC2, DynamoDB, S3, RDS, and you want to monitor those resources. You can use the CloudWatch that can give you the results. Coming to the CloudFormation, this service helps you in monitoring all your AWS resources at one place so that you can spend minimum time in managing those resources and maximum time on developing the application. So with the help of the CloudFormation, you can deploy the entire solution with the help of creation of a template. You just need to create one template and you have to deploy it. The rest of the things will be done by the AWS, and hence it is a kind of an automation task only. Now let's look into the demo of some of the essential services. So we'll start with the EC2, and I have already logged in into my AWS account. So where exactly you can find the EC2? Just click on the services. Under the compute section, you can find the EC2. EC2 stands for Elastic Cloud Compute Service, primarily used for creating the virtual machines. So I'll click on this service and quickly I'll show you how the virtual machine is created and how we can basically access it. So I would be creating one virtual machine or an instance with the Windows operating system. So here you can see there are 3 instances which are already running. Let me create another one. So you have to click on Launch Instances, and here you have to select some configuration details. So most of the configuration details I'll be taking as default, and wherever it is necessary I'll be making the changes. So first of all, you have to select the operating system in the form of AMI, and I would be looking for Windows 2016, and then you have to select the type of instance with respect to the CPUs, number of CPUs, and the memory capacity. So I'll go with T2.micro, which is a free tier eligible instance. In the configure instance details, the rest of the things we'll keep it as default as of now. Click on Add Storage. This is basically the virtual hard drive or the EBS, the Elastic Block Storage, that is attached with the EC2 instance. So primarily it is giving us 30 GB of space without any additional cost. We can leave the tags as blank. Click on Configure Security Groups, and here you can see that the RDP port is by default open, which will actually allow us to RDP or to have a remote connectivity of our instance. Click on Review and Launch. Now to give an authentication or to provide an authentication, we should have a key pair with us so that the AWS can understand or can tally the key pair and give us the access. So I already have a key pair created. What I'll do is I'll create a new key pair for this instance and put a random name. Let's say I put it something like demo. Download the key pair and make sure that you keep your key pair in a safe and secure place. Click on Launch Instances. Now you will see that there is an instance ID that has been created, which is a number, alphanumeric number, that is randomly given by the AWS. You can name your instances. So let's say we name our instance as Windows 2016. Click on Save. And the AWS deploys our instance on a respective infrastructure. It gives us the IP addresses, the public IP and the private IP, which is an internal IP. And we have to access the instance from the public IP only. So now to access that instance, we have to open up the RDP, put the public IP, click on connect, and when it asks you for the authentication, you put a username as administrator, and the password you have to generate by providing the key. So click on connect, and then you have to click on RDP client. Here you have to get a password. So click on get password, browse, and when you click on browse, you have to provide demo.pem file. So it should be in the download section here itself. Just provide that key pair, and it is going to give you the password in the encrypted format. Decrypt your password, copy that, and then provide those details to the RDP client. Click on OK, and now it should allow you to log into the instance. Let's wait for the windows to appear. So here you can see that we have logged in into the Windows instance. The Windows 2016 screen is available in front of us.
If getting your learning started is half the battle, what if you could do that for free? Visit SkillUp by Simplilearn. Click on the link in the description to know more.
In this particular demonstration, I would be explaining you about how to use a storage service, specifically the S3 service, which is most widely used service under the storage section. Now the S3 stands for Simple Storage Service, primarily used for storing the objects and the files. And what we need to do is we just have to click on the S3 service under the storage section. So when you click on S3 service, you have to create the buckets inside the S3. And the buckets are the places where you keep your folders or you upload the files that are available on your systems. So here if you'll notice that the S3 service is a global service. That means it is irrespective of the region. And the buckets when you create, they are created in a specific region. Now what is the benefit? The benefit is that if you create a bucket in different regions, all those buckets in different regions can be viewed from a single dashboard. And you don't have to change the region again and again to view the S3 buckets. So what you need to do is you have to click on create bucket, and here you have to specify the name of the bucket. So let's say I put something like demo AWS, and that's the bucket name I am going to select. Now make sure that the bucket name starts with a lowercase, and it should be always unique. Now why it should be unique? Because since S3 is a global service, so it may be that somebody else could be using the name that you have provided. So it should be always unique, otherwise it will not be allocated. Now you have to select a region, and that would be, let's say I go with the Ohio region. And in the bucket settings, you can basically change and configure these settings according to your requirement. By default, when you create a bucket, it blocks all the public access from the bucket. So when you have all public access blocked, no object can be viewed from the S3 bucket from a public network or by anyone else. And hence, in order to view the objects or the files in the bucket, you have to unblock or uncheck this option, so that first of all you make the bucket accessible from the public network. Likewise, you can customize as per the requirement, and then click on acknowledgement. The rest of the things we'll keep it as default, and click on create bucket. Now it says that the bucket with the same name already exists. So that means it is not a unique name. Somebody else might have been using this name. So I'll try to keep it more unique, and I'll try to assign some number. So let's say I put something like 987, and it says it is already existed. Let's say 9876, and then click on create bucket. Now if it creates a bucket, that means we have been allocated with that bucket name. So let's wait for a minute to get that bucket created. So that happens quickly, and you can see there are a couple of buckets already created here, and these buckets can be viewed in a single dashboard. So some of the buckets are in Mumbai region, some of the buckets are in Ohio region, but they are available in the same or a single dashboard. So I'll open up the bucket that I have recently created and I'll try to upload some documents. Now what you can do is you can create a folder also inside the S3, and when you create a folder you can upload the objects accordingly. Otherwise you can directly also upload the objects. So click on upload and we will upload any random file from my system onto the S3. So I'll basically file and then click on upload. Now it is uploading my object from my system onto the S3 bucket, and now it has successfully done. So it says the message is successful. Now in order to validate, I will click on the bucket from the S3 service and view this object. Now you can see here is my bucket. So I'll just open up this bucket and these DNS records.csv file is available with us. Now the S3 is not only limited till storing the objects or the files. It has many other functionalities and the features also. Like you can enable versioning, you can host a static website on the S3. Along with that, you can have a cross-region replication enabled so that you can have high availability of your objects, or you can have a redundancy of your critical objects in different regions. So likewise, there are more features that would be covered up in the detail section of an S3 service. Now coming to another section of the essential services, that is the database. Now here you can see I have a database section in the AWS and it has multiple services within it. The RDS is there, DynamoDB is there, Elasticache and the other database services are there. So I would be showing a demo on the DynamoDB, which is a NoSQL database. Now when we say it is a NoSQL database, that means it is a non-relational database service where we can create a database table directly from the web console. We don't require a separate database engine like in the case of RDS. And in the tables you can insert the values and view those values directly from the AWS dashboard itself. So it says Amazon DynamoDB is a fast and flexible NoSQL database service primarily suitable for IoT and web gaming and other mobile applications. So what you need to do is, it is a straightforward database service which can be accessed while creating a table itself, and it's a compute based database service. That is the reason that it is more fast. So click on create table. And what you need to do is you just have to put a table name. So I'll just put something like test. And in the partition key, so these partition keys are unique entities. So what you need to do is you have to specify a partition key. So I'll put something like ID. And the string, instead of string, I'll use a number. Likewise, I can add sort keys also. Let's say I put a name and the name should be in the string format. Now these are the unique entries. These are the fixed entries in the table. And after that, we are going to put the attributes, and in the attributes, the data will be inserted. So what you need to do is rest of the things we'll keep it as default as of now. Click on create. And here you can see the table has been created. The test table has been created. Now if I click on the items, so you would see that it has the sort keys available, the ID and the sort key associated with that, that is the name. But it does not have any entry because we have not added any value or the attributes. So how we can add or insert the values in this table? That can be done many ways. You can enter manually, you can use the help of CLI to enter the large chunk of data directly, upload it onto the DynamoDB table, and also you can use the APIs also in order to insert the data inside the table. So what you will do is we will click on create item, and in the ID we will put some value. Let's say number 1 string. Let's say we put something like we will go with a random name. So instead of putting any name, we'll put a value like ABCD. That should be fine. And then we will insert some attributes. So let's say I put string as rank, and I'll put something like rank 2 and then click on save. So here you will see, just refresh the database table, close it and open it up again. Click on the items. Now here you can see the ID 1, name is ABCD, got the rank 2. Likewise, you can click on create items. Let's say the serial number or the ID 2. Name, let's say we put something like, we can go with XYZ, any random thing. Put it up as number rank. And let's say this particular value got a rank 3. Likewise, you can add some more items. String, let's say you put something like HJK and you put a rank, let's say it's a rank number 1 holder, rank 1 holder, right? So likewise, this is just an example. Likewise, you can add the attributes as per your need, and the table can be filtered out based on the attributes also. So if you have to search some values in the DynamoDB table, so you can always use filters to basically search the values inside the table. Apart from that, the DynamoDB table has a lot of other functionalities. It can be basically, you can have a backup of a table created in the DynamoDB table, in the Dynamo database, and then you can retrieve or recover the data by restoring the backups from the DynamoDB. This database can be created in the cluster format also. So these are a couple of features that you can use with the DynamoDB. Now let's move into the next section. Now coming to the networking services, so there are some of the networking services which are very useful, and that includes a VPC, which is a virtual private cloud, CloudFront, Route 53, API gateway, etc. Now I will basically demonstrate about the Route 53 service in this demo. So in the Route 53 is basically a DNS mapping service. So what you can do is, let's assume that you are hosting any web application on the server and you want to route the domain traffic onto those servers. You need to have the help of Route 53 to do that. So what you need to do is, you just have to click on Route 53 service. And from this service, you can register your domains also. Otherwise, if you have domains purchased from any external site, you can point them to the Route 53 name servers also. So first of all, in the Route 53, you have to create a hosted zone. So there is already one hosted zone all created. Now, when you create a hosted zone, you have to specify the domain name. So let me show you. I have one dummy domain. This is the domain that has been defined. So what you have to do is, when you click on create hosted zone, you have to put a domain. Here you can see example.com. Likewise, you have to put your own domain and click on the public hosted zone. Click on create hosted zone, and it is going to give you 4 name servers. Now those 4 name servers have to be updated on the platform from where you have purchased the domain. So that is mandatory in order to route the traffic to the Route 53 service, right? So here you can see I already have a hosted zone created for a domain, and it has given me 4 name servers. These are the name servers, and these name servers have been updated in a record set from where the domain has been purchased, right? Once it is done, then you have to route the domain traffic to a server. So what you have to do is, you have to click on create record, and in the create record, you have to specify the IP address, or you can use the alias also, where the traffic should be routed to, where your application is hosted at. So ideally it is a server details, and it exists with certain policies also. So you can see some view existing records. So here you can see this particular domain is routed to a DNS value which is hosted in the Elastic Beanstalk. Instead of that, you can put an IP address of the EC2 instance also, you can use the S3 URL also, you can use the CloudFront URL also. So likewise, what would happen is that the domain traffic will be routed to the server where actually the application or a web application is hosted at. Now, I'm using a routing policy as simple routing policy. That means all the traffic should be routed to that particular domain. Whereas there are other routing policies also in the Route 53 that includes the weighted routing policy, which acts as a kind of a load balancing, geolocation routing policy, multi-value answer routing policy, and then you have a redundancy based routing policy, which is a failover one. So likewise, you can select as per your requirement. So what you need to do is you just have to click on create records. You have to specify, you have the domain, so you have to specify any particular info you want to put before the domain, otherwise you can leave it as blank. And in the record type, let's assume that you are using an IP address of a server where your web application is hosted at, so you can basically use A routes traffic to an IPv4 address and put an IP address. Make sure that you put a public IP address or the elastic IP address attached to your instance. In case if you are not using any particular IP address or the URL, you can use the alias also. So likewise, the records can be created. Along with that, the Route 53 services used for domain verifications also. Like if you want the email services onto your web application, then you can basically verify your domain directly from the Route 53 service. You can get the verification done for the SSL certificate creation. For that also, the records will be directly created from the Route 53 service because it is actually managing or hosting your domain. Now with respect to the security services, the most widely used service is the IAM, which is Identity Access Management. That lies under security, identity and compliance. So from the IAM, you can create the users whom you want to give an access to your AWS console. You can create groups and you can add multiple users in that group, give them the permissions. You can create the roles also so that multiple services can interact or integrate it together. So how the IAM is used, click on the IAM service and I'll show you how a particular user can be created and how the user is basically uses the credentials to access the AWS console. Now the IAM dashboard is open, and when you open up the IAM dashboard, it gives you the URL. So this is the URL through which the user has to actually access the AWS console by providing the user credentials. Now how the users are created, just click on the users and here you just have to click on add user. So I'll create one sample user. Let's say I put something like sample user. And what type of an access you want to give that particular user? Do you want to give a programmatic access, which is primarily the CLI access, or you want to give the AWS Management Console? So right now we'll go with the AWS Management Console access. Now, do you want an auto generation of the password or do you want to customize the password? So let's assume that we customize the password. So put any value. Make sure the password meets all the criteria and then click on next permissions. Now, what kind of permissions you want to give to that user? Let's assume that you want to give an access of a particular service only to that user. So you have to actually search a policy for that particular service that can be given an access to a user. Otherwise, if you want to give an admin policy or the admin access to that user, you can search an admin policy there. So the permissions are important, otherwise the user would not have privileges to access the AWS console. So we'll attach the existing policies directly. So click on it. And here, let's assume that I want to give an admin access to that user. So I'll just click on the admin access. Now to a particular user, you can give multiple policies also. It is not necessary that you have to give only a single policy. So you can provide a multiple policies to the users also. Now click on next tags. Let's make the tags blank. Click on review and create a user. Now you'll see that our sample user would be created, and to access the console, we'll just copy this URL, which has the account information as well. That is the account number. So copy the link, or you can copy the complete URL. Log out from the root account. And then paste the URL that was copied from the console. And then we have to give the user credentials. So we'll put sample user as the username and the password that we provided while creating the user. Click on sign in, and if it is correct, then it should allow us to log in into the AWS console while asking the password change. So we'll change the password. Confirm password change. And now it should allow us to log in into the root account's AWS console with the admin privileges. Now the next service is the monitoring services, and under the monitoring services, primarily the CloudWatch, the CloudTrail, the CloudFormation, these are some of the services that are most widely used. Now the CloudWatch is a service which is primarily used for monitoring the metrics, primarily of the servers. Like for example, if you create an EC2 instance and you want to basically watch out for the metrics associated with the CPU utilization or the storage utilization, the network in, network out, all those information you can get it from the CloudWatch. Now CloudWatch is not only related to monitoring the metrics, it can generate the alarms also, and here you can get the events also generated, which or the events that can be created which can trigger the Lambda function as well. So what you have to do is you just have to click on a dashboard. So monitoring metrics are viewed with the help of the CloudWatch. So first of all, you have to create a dashboard. Now you have to put a dashboard name. Let's say I put something like monitoring EC2. Click on create dashboard. Now how do you want the reports to be published? You have to actually select a widget. I want that, okay, the report should be visible in the numeric form. So I'll select a number. Now click on the dashboard that was created, and let's again add the widget. And here we'll select the metrics primarily for the EC2 per instance metrics. So we have one single instance running. Now there are 14 metrics available for that particular instance. Now I would be looking for the CPU utilization for this particular instance. So I'll just select for the CPU utilization, and it is going to give me some information about what is the current CPU utilization of that particular instance. So that is somewhere around 29.3%. The CPU utilization has been done for the single instance that is running in my EC2 dashboard. So likewise, you can add some more metrics and view them in this particular dashboard, and the CloudWatch will keep on publishing the data at a refresh interval of 5 minutes. That is the default value.
And with that, we have reached to the end of this session on cloud services. Should you need any assistance, PPT, or other resources used in this session, please let us know in the comment section below, and our team of experts will be happy to help you as soon as possible. Until next time, thank you and keep learning. Stay tuned for more from Simplilearn.
Hi there, if you like this video, subscribe to the Simplilearn YouTube channel and click here to watch similar videos. To nerd up and get certified, click here.